Hello, everyone, and welcome to the 2022 Big Blue Button World Conference. This is the third day of sessions, and today we are focused on administrators. This session is called Hiding Multiple Big Blue Button Servers Behind a Single Hostname. Load balancers such as ScaleLite allow you to hide multiple Big Blue Button servers behind a single API endpoint. As meetings are scheduled, users are redirected to different servers, each requesting media permissions. And today, talking and presenting is Daniel Schreiber. Daniel works at Chemnitz University of Technology in their IT department. His main task there is to automate IT infrastructure and develop Django applications. He and his team started adopting Big Blue Button during the pandemic back in 2020, and in 2021, he got involved in the Big Blue Button community. He started to submit patches, and during his talk today, he'll discuss his most recent work and help to open the door to new opportunities for usability improvement. Welcome, Daniel.
Thanks, Jazz. Thanks for having me here. Yeah, what we want to do today is, I don't see this slide here, the second slide. Do you see? Oh, it's here. Okay. What we want to do today is talk about a setup of BigBlueButton servers, which allow you to hide multiple servers behind a single host name. And why we want to do this is we want to avoid some things that users don't like about BigBlueButton, and that is that if meetings are scheduled on different BigBlueButton servers, they are asked about media permissions over and over again. So if you have, let's say, 100 BigBlueButton servers, the likeliness that meetings are scheduled on different servers is quite high, and users have to grant permissions over and over again. On other services, this is not required. For example, on Jitsi, you can run multiple servers of Jitsi for load balancing and capacity, but you're only asked for permission once. So, and with this setup, what we are discussing today, you can set it up in a way that BigBlueButton will ask you only once. So a second point that is quite nice about the setup is that if you're running a site which might have some load from time to time, for example, if you have big lectures with many people joining at once, then this means that a lot of traffic is hitting your server when the conference starts. And with the setup, you can keep this away from the BigBlueButton server and have this load on a different server. Take some time to load the slides here. Why? So the idea is that you hide all BigBlueButton servers behind a single DNS name. On a classic setup, you would just implement this as a reverse proxy. But in case of BigBlueButton, we don't want all the traffic go through the reverse proxy, because if you have, let's say, 100 BigBlueButton servers, you probably will have a lot of traffic for media stuff and so, and you want to have this traffic directly exchanged between the browser and BigBlueButton. So, so we have to separate the BigBlueButton UI, which is loaded from the reverse proxy, from all the other stuff. Which is exchanged directly with the BigBlueButton server. And of course, you want to have your site available during operating system upgrades and so on. So you likely have two reverse proxies which are clustered in a HTTP load balancer. But this is just classic load balancing technology, nothing fancy. And the good thing is that this is available since BigBlueButton 2.4, and you can run it in production. So it's no excuse for not using this. So let's have a look at what a session join looks like. So let's say we have a browser here which will start the session. It goes into GreenLight, and GreenLight generates an API, a join API URL, which redirects to the load balancer, which might be ScaleLite, for example. So ScaleLite then looks up its database, which BigBlueButton server is responsible for this meeting, and it will create a join API link to this direct BigBlueButton server. So this is the same as in a traditional setup, so it's all the same. Nothing changed here. The difference starts now. The BigBlueButton server knows that the client UI has to be loaded from the cluster proxy, and it will create a redirect URL which directs the browser to the cluster proxy here. The cluster proxy delivers the UI, the HTML5 UI, and as you can see in the URL of the browser is the URL of this cluster proxy, and this is always the same, no matter what BigBlueButton server runs this conference. So then the BigBlueButton client has loaded and starts exchanging messages between the BigBlueButton server. For example, it's updating chat, it's establishing media connections like audio and video, and so on. Loading slides, so on. So there were some challenges in this setup. The first challenge was that the BigBlueButton API uses a session cookie. So the first idea was to use to proxy also the API through this reverse proxy, but this was not a good idea because in that way you would probably or likely share secrets between different instances of BigBlueButton servers. So if we have our UI running from the cluster proxy, and the browser wants to make API calls to the BigBlueButton server directly, then you have to permit the browser this. Usually browsers don't do this. So the way to do it is add course headers for this. So there were some tweaks that had to be done to add these course headers, some in the setup of BigBlueButton, some in the configuration of BigBlueButton. So let's have a look what we have to do to set this up. First, have a look at the reverse proxy. It's quite simple in the reverse proxy. You can use any HTTP web server like Nginx, Apache. I've tried both. It works with both. And in this case, we have a look at HTML5 setup in Nginx. So you might have seen this configuration snippet in BigBlueButton server, but with one difference. And the difference is, let me pick the drawing, is this one. So you add the BigBlueButton server in the location. So remember, this is on the reverse proxy. And what we do is we proxy this to the BigBlueButton server BBB01. Again, on the BigBlueButton server itself, we have added this one here. And this part and this part have to be equal. From this setup point, that's all you have to do if you don't want to do caching. If you want to do caching, you have to add another location match, which is actually proxying again to the BigBlueButton server, but it adds caching here. I have to set up this proxy cache. And it's caching all 200 requests, responses, and 301 responses for 60 minutes. So that if you upgrade your BigBlueButton server, it's still safe. It's safe for a different reason, because BigBlueButton assets like JavaScript and style sheets are using content addressing. So they are using, I think it's the SHA-1 sum of the content as the file name. So if you install an update, you will get a different file name, and therefore it doesn't matter if the cache on the reverse proxy is stale. It will be a different URL. So on the BigBlueButton node, you have to configure more things. The first is the BigBlueButton API. So the API is BBB Web, and you have to add the BBB Web properties. Here, for example, this one, the HTML5 client here. This one is the redirection to the proxy. So this default HTML5 client URL means that the client, the API, will send a redirect to the proxy. Again, we have here the node name included in the URL. Presentation and guest wait page directly served from the BigBlueButton server, but it has to be configured here. If you don't configure it, it won't work. Again, on the guest wait page, you've got the node included. On the API, you don't. And these access control allow origin configuration means that this is the permission for the browser to make API calls to the BigBlueButton API from the reverse proxy. For HTML5 client, there are also some settings which have to be set up. First of all, it's the base name. Again, here we have the node name included. And we have the web base, which is actually a setting for where does the HTML5 client find the BigBlueButton API. This here is the BigBlueButton server itself again, as well as for the learning dashboard, for the Sun servers, and for the zip WebSocket, which is for research. The Meteor, which is the software which runs the HTML5 client, needs a configuration tweak. Again, here we need the server included the relative path of the HTML5 client. Okay, we are almost there. The last thing is that you have to tell the BigBlueButton server itself that it should serve the HTML5 client from this location here again. So if you're deploying this with tools like Chef or Ansible, you'll likely generate this BBB HTML5 Nginx file and the other configuration files using some kind of templating. For the guest lobby, there was a bug in the original setup instructions. The guest lobby loads the translation files directly from this location /HTML5 client locale. So this is hard coded in the HTML5 file, and we can fix this using a redirect here in this proxy. It's not in the proxy, sorry, it's on the BigBlueButton server. So, does it work? Yes. We run this since February this year, and also InfraRun, who run the BigBlueButton servers for all schools in Berlin and some smaller universities in Germany. They also have the setup, and it just works. Okay, that's it from my talk. If you want, we can have a demo. We can have a look at our BigBlueButton server. Have a look in the developer settings. And yeah, I'm ready to take some questions. So let me look in the chat. So the bandwidth is that of the reverse proxy. Nicholas, I don't know exactly what you mean. So the WebRTC traffic is always exchanged directly between the browser and the BigBlueButton server. So all media traffic like audio and video does not cross the reverse proxy, because in that case it would be a bottleneck. A wildcard domain rule. Is cluster proxy a single point of failure? No, it's not if you run 2 instances of it and use classic load balancing. So you can use something like KeepAliveD to share a virtual IP for the reverse proxies. So then they are highly available. WebSocket traffic does not run through the proxy, no. So even if one machine crashes during a session of BigBlueButton, the session is not affected. Do you get better scalability from BigBlueButton server because it does not have to serve the client directly? Yes, you do, if you have a high join rate of users. For example, Greenlight 3.0 will join users immediately when the meeting has started. So, for example, if you have a lecture with a few hundred users will join within, let's say, a second or two. And this will likely affect the bandwidth of your server. For example, if you've got only a gigabit connection on your server, and there's a screen sharing involved in a different meeting, which means that you're sharing screen with, like, let's say 800 megabits screen share bandwidth, which is already consumed, then there's not much room for delivering the HTML5 client. And with this caching, the client is served from the reverse proxy, and only the first request hits the BigBlueButton server, and the others are served from the cache. It is documented, yes. And if you find an error in the documentation, then please ping me and I'll fix that. Samuel, a wildcard subdomain rule in Nginx not to enter each server. Actually, I'm not quite sure if this works. We use Chef for deploying our servers, so it's not an issue to render a template. And it's not, the setup is not a replacement for ScaleLite. So this is an addition. And there is a patch which I submitted a few minutes ago, which adds the opportunity to save the settings, like notification settings, like when someone's joining in the session that you get an audio notification or these kinds of notification. These settings can be stored in the local storage from the browser instead of the session browser, with session storage, which is the current implementation. And if you use local storage for it, it will keep these settings across meetings. So you join any BigBlueButton session of your university, and last time you have set up you want audio notifications when somebody joins, then it will be initialized that way. So network traffic, only the HTML5 client goes through the reverse proxy. Everything else is exchanged directly. So it will load the HTML document, it will load the JavaScript, the CSS, the assets for virtual background, and so on. All these assets are loaded from the reverse proxy, but connection to MediaSoup, connection to FreeSwitch, connection to Meteor, which is the WebSocket connection, which is responsible for updating the client when, let's say, someone is doing a chat message. This is all exchanged directly. So there's no change as before. It helps with the stability of the HTML5 client. No, it helps with the stability of the media traffic. Media traffic, it takes away some network load from the BigBlueButton server because the reverse proxy will cache the client, and it will serve the client from its cache. Client URL also be used. I don't know what this option means. So it helps with the stability of the BigBlueButton media, because media is UDP and it might be a saturated connection, and so the other clients will load HTML5 client from the reverse proxy. Have a look what the join API means with the client URL. I don't know if the client URL is an override for the default client URL, and I've not tried this. Does probably, or maybe it overrides this default client URL setting I've shown in some slide ago. Check. I don't know if this overrides this one here. If it does, then this would be a good opportunity to run multiple reverse proxies. For example, if you're a BigBlueButton provider and want to create multiple reverse proxies, each for one customer, because the customer wants to see their DNS name in the browser. This might work, I don't know. This is part of BigBlueButton since 2.4. So we are running 2.4 with our own packages built from the source, but without any further modifications. So you can just take the packages, the official packages, add these configuration settings, and it works. With the exception that the persistent storage in the storing of the settings in the local storage, this is not yet merged. So if this gets merged, then yeah, you can help reviewing it. Let me check for the link. Best is this one. Without having to change the server config. Actually, most of the configuration options are just that you configure the client to use direct connections to the BigBlueButton server. There's only this course setting here, and this default HTML5 client URL, which is pointing to the reverse proxy. So what is the purpose, or what do you want to achieve if you want to not change the server configuration? You have to change the server configuration because at least you have to add these course headers. Okay, just an idea. Yeah. White label HTML5 clients, I think you can have them. If you allow multiple origin, access control origin nodes, I don't know if it's possible, but I think it should be. Yeah. Then you just have to add all of your reverse proxies which you're operating on. Then it should be possible. Maybe you can try and yeah. Okay. We can have a look in the browser what this looks like, and yeah. So let me take the Firefox here. So I've started on our test environment, but it's similar on the production environment. The test environment has this persistent patch in. And I've enabled in Firefox showing of network traffic in HTML5 and WebSockets. So let's start. So first, what you can see here is the request on GreenLite for starting the session. Then GreenLite redirects it to ScaleLite, and then it will redirect it to the BigBlueButton server here. And the BigBlueButton server, if we have a look here, sends a location redirect to our BigBlueButton frontend. And as you can see here, in the response, that's the HTML5 client. And this WebSocket here is the Meteor WebSocket, and this one is for FreeSwitch. So if you want to join, you can paste in a link here, and you can try it out. And last time I had, I think I had set up, no, I did not. Let me check here that I get an audio notification once a user joins. I will leave the meeting and join again. And it should be there, the setting. Yeah, here it is. You can see this is participant joining is enabled again. Okay. That's it from my side.
Thank you so much for sharing, Daniel. That was all super fantastic, a really awesome presentation. And thank you to everyone who commented and interacted in the chat and asked questions. That's what this conference is all about, right? Just sharing information and collaborating together. So there's a link in the chat for the next session, which begins in just a couple of minutes. And the room for that session is already open. And that session is hosted, it's an hour-long session, and it's hosted by Daniel Mulkinton and Annika Herring. And they're going to be doing a whole bunch of things. They'll be talking, there'll be a lot of interaction, there's going to be a workshop involved, and they're going to be talking about Scale. So yeah, fantastic. Thank you again to everyone who joined. And again, thank you so much, Daniel, for this really just fantastic presentation.